Okay, so today I'm gonna be solving this problem. I already solved it today, but I wanna record this attempt. And also, if I check a couple days ago, or like a couple years ago, also was solving that. Today I'm gonna be solving that in Rust. So this is the statement. So the problem is minimum score triangulation of a polygon. So what's given? There is like n vertices polygon, and it should be split into triangles, so they can be maximum and like only vertices of the polygon should be used in this split, and they might be maximum n minus 2 triangles, and I should split it in a way that minimizes the score, and the score is the sum of the scores of triangles, and score of triangle is just the multiplication of its vertices. So in this case, this 1, 2, 3, it's gonna be just one triangle, and that's 1, 2, say clockwise, 1, 2, 3, and then the score gonna be 1 by 2 by 3, so it's gonna be 6. It's like trivial case. So the second case is less trivial, so it's like now 4 vertices, so 3, 7, 4, 4, 3, 7, 4, 5, and then it can be like 2 split. The first split is like this, and then the score gonna be 3 by 5 by 3. It's gonna be 105, and plus, so it's gonna be 3 by 5 by 7, and plus 7 by 4 by 5, and it's gonna be 140, and the sum gonna be 245. That's the first split, and the second split would be a split like this, and then the second split gonna be score 1, score 2, and it's gonna be 4, so it's gonna be 5 by 4. Is it 5? Yeah, it's 5. 5 by 4, 20, by 3, 60, plus 12, so it's gonna be 4 by 3 by 7. 12 by 7 gonna be 84, so it's gonna be 144. So, and clearly this split is better because previous one was 245 and this one is just 144, and I should return the 144 as a result. So the idea of a solution, let's review the idea of a solution that I have. So let's say we have this 1, 2, 3, 6 vertices, and let's say we have 1, 3, 1, 4, 1, 5. So the idea is to split this problem into 2 subproblems. So basically I can start from first and last vertex, and I know for sure that this side gonna be included in a triangle. The question is how I should I split the space? And let's assume I draw a triangle like this. I choose it like this. So now the score becomes something like this. Score of this, let's say shape, let's say call it V1, V2, or let's say S1, S2, S3. So score of this split gonna be just a sum of scores, s2 plus s3. And then if I just gonna number these vertices, like starting from 0, 1, 2, 3, 4, and 5. So the score for this middle vertex is gonna be just so it's gonna have like middle shape is gonna have a shape of triangle, and it's like already trivial case, so the score of S2 gonna be just 1 by 4 by 5. And then the subproblem splits into this one, so let's say it was answer to the 0, 5 shape. So it starts at 0, ends at 5. And then this one gonna be the score for the shape A, starts at 0, ends at 3. And this one gonna be the shape, the score for the function that's for the shape that starts, let's say, at 3 and ends at 5. And I can keep iterating this left side and right side until the size of the shape becomes 3. If it becomes 3, I just calculated this in this middle part. If it becomes less than 3, I'll just return 0. And if it's more than 3, I'll keep splitting it up. So in this case, it's more than 3, and in this case, it's 3. So I can calculate this score trivially, and I can calculate this one, but iterating again. So I start from two vertices that connect first and last, and again I do the same. I choose randomly this one, this size, or like this vertex, and try to calculate the score of this and this. So this is pretty random selection, but what I need to find is minimum. So I chosen this vertex, but in reality I should try splitting up every possible way. So I should split up, if I have this side, I should try to use this vertex and then the rest. So this one, calculate the size, the score of this one, and then calculate the score of the remaining part, and then I should calculate calculate the middle one, and then calculate the top one, and then calculate the bottom one, and then I again move the vertex. Again, I calculate the score for this one, and this one, and check if it's like minimal. And then I move the vertex like here, and again I draw the middle one that becomes this one, the left one becomes this shape, and the right one is just empty, so it's gonna be just 0. And then I can output the score. As you can, as I noticed, these shapes can repeat, and I can store the interim result, or like the result that already has been calculated in a 2D array, like 2-dimensional array. And the first dimension gonna be the start vertex, and the second dimension gonna be the end vertex, and the value gonna be the score of this shape. And then I can like efficiently calculate everything, and because like they're gonna be n vertices, so they're gonna be for this side I need to check like here I need to check like n minus 2 vertices, and then for every multiplied by something question mark, and this something question mark can be O of 1 if it's already pre-calculated, and can be something. But yeah, that's it. So I will start writing the code for this one. So I will use this Rust rover because I'm not very I'm still learning Rust, and that can help me drafting the solution. So this one, I have this abstract and implementation, and then I'll start. Let me start doing this. So I'll have the cache. Let me mute cache equals vec. So let's say I have n, let n equals values then, and then I'll have this vec of the size of value vec the size 0 n, and then it's now gonna be n, size n, and then I'll have the let me mute min equals I32 max initially, and then I'll have the function pub. Let's say we return pub like just a fan dp, and then I'm gonna have this start I32, then end I32, and then I'm gonna have values. Let's say these, let's say values are gonna be, let's say values, okay, and then gonna be vector I32, and then I'm gonna have cache gonna be mute borrowed reference to this cache. Yeah, and then I'll return 0, but before returning I'll call it p as start 0, and I'm gonna be n minus 1, and then I'm gonna values. Let me just push the values. Then here I'm gonna be the reference to the values, and then cache. What's interesting is if I can just move it there, dp, let's say mute. Yeah, just move it. White thread. Okay, solution. dp. Okay, usize here, usize here, and then I'll check if cache. Yeah, it should be the reference, and this one should be the reference. Why? Because I'll have at least 2 branches, like go to the one side of the shape and then go on to the other side of the shape, and then if I'm just gonna move, I won't be able to use this variable in the other usage of the function, of the dp function. So I need preferences there. So I'm gonna be address mute, and then here address, and then I'm gonna have just mute, and then here I'll check if cache at start and end not equal 0, and then if so I'll just cache, return cache. Otherwise I check if end minus start is less than 2, and if so I'll just return start less than 2, and if so I just return 0. Okay, 0, and then here I'll check the so I need for let's say k or I go through the so from the start plus 1 till the end, and then I need to go let mute res equals i32 max, and then here I'm gonna go result. Okay, so first I'm gonna calculate the middle triangle. The middle triangle score gonna be, let's say, let m score equals values, start by values, and by values values I, and then I will add let's say let mute m score, let's say 0 initially, and then m score equals this one, and then I'll go like res current equals this one plus dp s, and then I from s to I, then all this plus solution the same from I to n plus to the end, okay, and then result gonna be compare mean result and current, and then I'll return the result, something like this. Okay, something like this, and that should be the solution. Oh, I also should save this in a cache as cache as e equals result. Okay, let's try to run it and see if it succeeds. Solution here. Okay, that's it.